Hey everybody, welcome back to Math. We've got this, Mr. Stewart here. And in the last video, we were taking a look at how to simplify algebraic expressions using the exponent laws. As we start this one off, what I want you to recognize is that we are multiplying together two expressions. And these expressions themselves include multiplication. These are often what we call the product of two powers. You might see that term or hear about that at some point in the future. Okay, so it's a product of powers. Now, as a strategy or as a tool for solving, what we've done over here is because we're multiplying every single term together, okay? So we're multiplying the product of powers together, and within each of those powers, there's multiplication between the terms. So what we can do is we can apply the commutative property. Now, to commute terms means that you can change the order in which those terms are presented. And not only presented, but in this case, it's the commutative property of multiplication. So the order in which you multiply terms together will not impact or change the answer. And you can prove that to yourself just with a simple numerical example. Mix the order up, multiply, see what you get. And I'm willing to bet you will be seeing the commutative property in action. So why we're doing this is it sets things up so that we can quickly identify the rules and the laws that we're using to multiply these. Okay, and yes, so we can apply the commutative property. Sorry, I just had to pause the recording there. I didn't take a quick message. So we're back in action here. So what we can do is we can apply the power rule. Sorry, not the power rule, the multiplication rule to that first set of powers. We'll continue with multiplication between these two groups, and we can apply the multiplication rule to that second pairing of terms. So you might be wondering, well, why am I doing that? Well, let's take a trip back. Let's remember that, I'll highlight this here, is that we have powers of the same base. Okay, so we can write that as a single power using addition because we're multiplying. So we can take these two exponents together, we can add them up. And that, of course, is all due to the multiplication rule, or the multiplication property. Let's write that in as our communication or justification of what we're doing. Perfect. All right. Last but not least, let's tidy this up. So that means we have a to the 8th multiplied by b to the 7th. And we can drop the dot notation and just express it as a to the 8th, b to the 7th. And there you have it. So if we check our recording time here, we are at a total of 3 minutes and 22 seconds. Let's start the last one off, then we'll pick it up in the last example. Okay. All right, let's zoom in on this. Wow. Okay, this one is looking really, really busy. Okay. This one's, we've got some work to do. Okay, but not a problem. We can handle this. We just have to break it down. So let's start with the numerator. Okay, so what I want you to recognize is that across all of these terms, so -2, let's grab the highlighter here. -2 is being multiplied by u, which is multiplied by the power, v to the power of 3. That power, or product of powers, is being multiplied by 8, multiplied by u cubed, multiplied by v squared. So I am using that term multiplication, right, to multiply an awful lot, because that's going to spill over into the exponent law that we end up using. We just need to justify why and how we're going to use it. So remember back, we're running out of time here. Remember back that in the previous video, we were breaking up the terms using the commutative property. So I'm just going to do a quick reorganization here. Actually, I'm going to re-express. I'm going to drop out multiplication symbol. I'm going to split these up using the dot notation. And I'll do the